Hi, in this video, let us discuss solid principles. Solid principles are actually object oriented design where it is we use for easy understanding, maintainability, flexibility while we are working in a projects. It's like mainly for easily the code should be extensible, reusable, modular, readable, testable. So these are very famously we used in modern softwares. Let's discuss one by one. The first one in the solid principle is single responsibility principle. Suppose let's discuss here there is an bird class and we have two functionalities, that is fly method and there is an make sound. So suppose if the species is sparrow, we have this function. If the species is eagle, we have this. If the species something that this bird is flying, then like similarly the sounds. If you observe here, there are multiple if else statements. Like suppose if there is an 100 species, it's very difficult for understanding of the codes. So that what we are going to do for for what single responsibility principle says, for easily maintainable and like easily should be looks like scalable, what will you do? We will just make the each class we will assign only one responsibility. So instead of bird having multiple responsibilities, we just created for the flying behavior one interface and sound we have one interface. Suppose the each class, whether the sparrow, eagle, uh, we have implements both functionalities and the corresponding this. So this is how single responsibility principle. So, by assigning the class with only one responsibility, we are able to have good maintainability, readability, and flexibility in the code base. Let us discuss now open or closed principle. Suppose take an class drawing where we have function draw shape. So if we give some shape that is getting the type where it has like circle or square, if you observe here there can be so many shapes. So it just affect uh, if we want to add more shapes, we need to rewrite the original code again. We should change so as many times it required. But instead of that, let's just do separate into classes like this. If we can do what this principle is saying, through this we can extend, we can it will be open for the extension. We can add so many classes for the shapes, and it is closed for the modifications, like we need not modify the existing codes. Let us talk about Liskov substitution principle. Here we have the class rectangle, and we know the square is nothing but a rectangle where all the its sides are equal, so it's just extends the rectangle. So this is the code, but the actual problem is when it inherits the properties. In square we have length and width both are equal, right? So always we'll try to set the width, like if we got width we'll try to equal with the height, or if we get the height we'll try to equal with width. So when we do this function, it will affects the code in rectangle. So what Liskov substitution principle said, whenever there is a super class, the sub the should be replaced with the subclass, the object of subclass, if and only if it doesn't affect the correctness of the code. So for that what we are doing, we are just taking one abstract class that is shape kind of interface, then we are from that we are taking it separately, like from the rectangle extends the shape and the square extends the shape, like this. Now let us discuss interface segregation principle. Here let's take one interface that is UPI payments, where we have pay money, get scratch card, and get cash back as credit balance. These three features. Now we have Google Pay, which implements these UPI payments, so that we have these functionalities, all these three. Suppose there is a Paytm is there. Suppose the Paytm when it implements UPI payments interface, it don't have this functionality get cashback as credit balance. So for that, what we should do is we should create one future new interface, that is cashback manager. So we will do in the UPI payments whatever this future, we will just cut it and we'll just put in this interface. So exactly what we are going do here is we are just splitting the larger interfaces into smaller interfaces. It's quite looks like a single responsibility SRP. So now you can see now Google Pay will implement along with UPI payments. I will also do with cashback manager, so that it implementing all these three functionalities. Suppose whether it's Paytm or phone pay, where we need not compulsorily override, so that we'll just removing this get cashback. Let us discuss now dependency inversion principle. Suppose let's take one class called credit card class, where we have one method do transaction. It has payment using credit card. Then similarly, let us have one more class debit card. It has do transaction same method, and here we are printing using debit card. So now in the shopping mall, let's have this class where we injected this object debit card, and you can see in the shopping mall we use that constructor. Then we are calling making one new method do purchase something. Here we are doing debit card dot do transaction. So whenever you are doing this, creating the debit card, and in the shopping mall creating the new shopping mall object with the dependency debit card. So you can observe here it is tightly coupled with the debit card here. So whenever you go some shopping mall, you want to do some transaction using debit card or credit card, it's like you should have some choice. If you run this code, so we are using now debit card here. Suppose instead of debit card, if you want to use credit card, you should change entire code. So it will little bit so tightly coupled, so entire code you need to change. So for that reason, we just using one interface, that is a public interface bank code, where we'll have here the method this transaction here, and then this credit card both will implement the our bank card. Similarly, we will do same thing. We'll do same thing with the debit card also. Now, so instead of instances of debit card, let's create private bank card. So let's just change these codes here. So after changing the codes, you can see here instead of here bank card, we can use a credit card, and we can run this code. So payment using the credit card. Suppose if we want a debit card, we can run this code. So payment using debit card. This is how we can achieve loosely coupling.